Good morning, good afternoon, good evening. Welcome to Electrical Machines Lab, and this is the experiment 4. We will do some tests on wound rotor induction motor. So this is a 3-phase wound rotor induction motor, and the serial number of this machine is 823100. So now first of all we will note down the readings from the nameplate details. So first thing here, it is voltage of the stator winding. So what is the voltage of the stator winding? It is 120 volts, and current is 1.5 amperes, and the rated voltage of the rotor winding is 60 volts, and the current is 2 amperes. The 3 rotor windings are star connected, right? And the rated speed, it is 1500 revolutions per minute, and the mechanical output power of the rotor is 175 watt. Okay, so these are the nameplate details. Now coming to open circuit test on this machine. So see here, it is connected from 1 to 3. Take wires from 1. From 1 it is going to watt meter. So this is the watt meter, so we can use any 1 watt meter. So we will connect from 1 to watt meter 1, and from 2 to watt meter 2, from 2 to watt meter 2, and 3 to watt meter 3, and then take 3 wires from watt meter 4 to our AC ammeter 1, and from 5 to AC ammeter 2, and then 6 to AC ammeter 3. Then from AC ammeter 2.5 to 1, and then AC ammeter 2 to 2, stator connection 2, and from AC ammeter 3 to AC our stator winding 3. Then we have to short this 4, 5, and from 5 we have to short 6, and then from any 2 7 from voltmeter, AC voltmeter 250. To common, right? So this is our circuit diagram. So you can see once, and here for working of our wattmeter, we have to connect a external power wire, low voltage circuit from 24 volts to low power input. This will not be shown in the circuit diagram. You have to remember this. So now go to the procedure. So what we have to do, we have connected the circuit and increase the input voltage in steps till it reaches the rated value. So what are the readings we have to take here? So here in the table it is given to note down the readings of open circuit voltage and current W1, W2. So first of all, what we will do, so to increase in step, here we have direct 120 to 208, so we cannot increase in step, so we will change it to 456. So in 456 we have from 0 to 120, so we can increase the voltage in step. Now switch on. So now see the first thing, I naught. See I naught, it is not showing very much this thing, so we will change to 0.5. So first of all we will put a voltage of output voltage of 40. So we connected to 250. So 20, 30, 40. So now see the current here. So current we have connected for 0.5. So it will be 0.25. And power, see here it is going back. So this is our W1 and this one, yeah. So this W1 is in negative and W2 is positive, and W1 you can see the reading here, and W2 you can see the reading here. So that you can see the switch positions for W1 and W2. So I will show you the whole thing. See the readings and switch positions you can see now. Now just increase the voltage to, so here I am changing the position to 2.5, so that when the voltage increases to 60, it may go beyond 2.5. So now for 60, this is the readings, and now it is connected to 2.5. So observe this change, and this is our wattmeter position. Then increase to 80. So these are the readings for ammeter, and these are the readings for wattmeter. Now again go for 100. So these are the current ammeter readings, and these are the wattmeter readings. Now from 100 to 120. Okay, maximum it is taking 110, so take 110. So this is our ammeter reading and this is our wattmeter reading. So this is our no load test. So remaining calculations you can calculate. Next text is the locked rotor test. So here the only change in the circuit is here this which is connected in the open circuit test for a voltmeter. So we will remove this and we will short circuit this 7, 8 and 8 and 9. Okay, and we have to lock the rotor so that it will not rotate. So what we have to do now, we have to hold the shaft, this one, like this with the hand, and we have to increase the voltage. Okay my dear, so like this we have to hold the shaft of the machine. Now we will increase the current to 0.5. So here we have connected to 2.5. So this is 0.5. So now see, the machine will not run. It should not run. We are conducting the locked rotor test, so the machine should not run. And this is our wattmeter reading. So this is going back. So we will change the position of the switch. And then next we will increase the current to 0.7. Okay, and this is our wattmeter position. Now increase to 0.9. Now this is our wattmeter positions. Then increase to 1.1. This is our wattmeter position, and then increase to 1.3. So this is our wattmeter position. So next test is no load test. No load test, we will not conduct any test here. We will take the readings from the previous test, open circuit test. So here I no load, rated I no load, you can take at the V rated voltage, that is 110 volts. So at 110 volts what you got, the current, it is the I no load. P no load is the P naught, which we have calculated at a open circuit voltage of 110 volts. And P iron plus P copper, that is you have to take from the open circuit test, that is whatever the P naught is there, that is the losses. And rotational losses you can get from P no load minus P iron plus P copper. So P iron plus P copper, those losses we have calculated from the open circuit test. So if you see, from the open circuit test we have calculated the P iron plus P copper. So those we have to substitute here, P iron plus P copper. Okay, so P rotational you can calculate from subtracting this two losses. Next one is the load test on wound rotor induction motor. So how we will conduct the load test? So here the circuit diagram is same, and additionally we will connect two wires for the prime mover. So this is one prime mover 1 to here 1 and 2 to prime mover 2. Here to see the display we have to give the low power input here. So connect a wire from low power input to here. So now follow the procedure here for the load test. So for the load test, what we have to do, we have to run the motor at rated speed. So you can see the speed here. So switch on the power supply and increase the voltage. So slowly the machine will be running. To measure the voltage, so to measure the voltage, connect a voltmeter here and apply a rated voltage 208 volts, and this is the speed. So note down the rated speed, and the torque here is 0. Now what we have to do, we have to increase the torque. Note down the readings for torque 0. What is the speed here? This is the speed, and this is the input current rating, and these are the wattmeter position. This is going back to change the position. So this is the wattmeter position. Then increase the torque to 0.3. So now check the ammeter readings and check the wattmeter readings. It is going again back, so change it. So this is the position and the wattmeter readings. Now again increase the torque to 0.6. This is our ammeter reading and this is our wattmeter reading. Now increase the torque to you have to note down the speed also. This is for 0.6, and for 0.3 what is the speed? For 0.3 the speed is this one, and for 0.6 the speed is this one. Now increase torque to 0.9. Now the speed is the speed. This is the ammeter reading, and this is our wattmeter reading. And the last one, we will increase the torque to 1.2. So for 1.2 the speed is this one, and this is our ammeter reading, and this is our wattmeter reading. So remaining things you can calculate from the calculations, and you can draw the graphs. Thank you.